Hi viewers, yeah, welcome to my channel. Today's topic, let's look at factors that affect chemical system in equilibrium. By the end of this lesson, you should be able to know how to state the Chitterius principle and describe the effects of these factors that affect chemical system in equilibrium. Okay, so the factors that affect chemical system in equilibrium include the change in temperature, pressure, and concentration. So we're stating the Chitterius principle. So the Chitterius principle states that if an external constraint is imposed on a chemical system in equilibrium, the equilibrium will shift so as to annul or cancel or neutralize the constraint. So let us look at the effect of change in concentration. The concentration of the reactant and that of product is equal in an equilibrium mixture. So look at this reaction. So at equilibrium, the concentration of hydrogen, the reactant, and the product are equal. So what happens if I offset this balance by introducing more reactant? By increasing the concentration of the hydrogen, and you're increasing the concentration of hydrogen gas, what happens? The reaction is going to occur in order to consume the reactant that they added, to consume it and produce more product. So if you increase the concentration of the reactant, the equilibrium position is going to shift to the right to favor product formation. If you increase the concentration of the product by adding more products, by adding more hydrogen iodides in this reaction, so the reaction is going to occur in order to consume that added what I've added in this product and shift it to the left to favor reactant formation. So what happens when you remove either the reactant or the product? As the product is being formed, you remove more. So what happens is that every production is going to shift in order to restore that species that's been removed. So what it means is that as I remove the product, more is being formed. So when you remove the product, what will happen to the position of the equilibrium is going to shift to the right, favoring what? Product formation. So what happens if I remove the reactant and remove reactant? Equilibrium is going to shift as to restore that was reactant. So as you remove reactant, more reactant is what is formed. So take note of this very well. Take note of this point, it's very important. So you can be asked, if you are asked the position of shift in position of equilibrium, what I want to expect you to say is whether it shift to the right or to the left. So in a nutshell, if you increase the concentration of the reactant, every position is going to shift to the right, favoring product formation. If you increase the concentration of the product, every position is going to shift to the left, favoring reactant formation. As you remove reactant, more is being what formed. What will happen to the position of equilibrium is going to shift to the left in order to restore that reactant has been removed. So as you remove the product, more is being produced. So equilibrium position will shift to the right, favoring product formation. So that's all about what? Effect of change in concentration. Effect of change in temperature. Chemical reactions are accompanied by changes in heat energy. A reaction may result in a production of heat or absorption of what? Heat. So look at this equation. Production of what? Ammonia gas. You can see the enthalpy change is minus, that's exothermic reaction. So it means that the forward reaction is exothermic and backward reaction is what? Endothermic. So this reaction is at equilibrium. What happens when you offset this balance? By increasing the temperature. So when you increase temperature, equilibrium is going to shift in order to shift the direction that will absorb the heat. If you lower the temperature or decrease the temperature of this system, equilibrium is going to shift to cancel the cooling effect by releasing more heat. So when it comes to the effect of temperature, what you should look at is what? The heat, the enthalpy change, the enthalpy. Is it exothermic? Is it exothermic? So since this reaction is exothermic, means it's releasing heat. So increasing temperature of this system, when you increase the temperature, it will not favor forward reaction. It's going to favor backward what? Reactant formation, or it's going to shift backward. Equilibrium position is going to shift to the left, favoring reactant formation. So, but if you lower the temperature or decrease the temperature of this system, equilibrium position is going to shift to the right, favoring product formation. So, easier way to know this thing, to avoid confusion. What happens to equilibrium position if you increase the temperature of this system? You look at, okay, this exothermic reaction, it is releasing heat, the reaction vessel is hot. If I increase the temperature, it won't favor the, it won't be good for the system. So, everybody's going to shift to the right. If the enthalpy sign is plus, what happens if you increase the temperature? Okay, this endothermic reaction, it absorbs heat and the reaction vessel is cold. So increasing temperature good is going to favor the forward reaction. What if you lower the temperature of this system? This endothermic reaction is absorbing heat and the reaction vessel is cold, and you lower temperature again, it will not favor the forward formation. So that's the easy way to know it. Alright, another thing I want to talk about is what? Equilibrium constant. Pressure and concentration doesn't have any effect on equilibrium constant. So it's constant for pressure and concentration. So what happens is only affects your temperature, effect of temperature change in a chemical state equilibrium. Anything that shifts this thing to the forward, shift the equilibrium to the right, favoring product formation, will increase the value of the equilibrium constant. Okay, look at this system, this endothermic reaction. If you increase the temperature of this system, if you increase the temperature, what will happen to the equilibrium concentration? So, increasing the temperature of this endothermic reaction will shift the equilibrium position to the right, favoring product formation. So, equilibrium constant is going to what? The value of equilibrium constant is going to increase. If you lower this temperature, decrease the temperature of this system, it's going to shift it to the what? To the left. So the value of K will decrease. The value of K is going to do what? Decrease. So that's all about what? Effect of temperature. Alright. So there's a relationship between temperature and equilibrium constant, the reaction between them. So call that equation Van 't Hoff equation. Delta H is molar heat of what? Reaction. So if you are given an equilibrium constant 1 and 2 at temperature T1 and T2, and I ask to find the molar heat of reaction, so we make this one set the formula. Let's summarize the effects of change in temperature. So reversible reaction, where the forward reaction is exothermic, means this forward reaction, if I put delta H, it will be minus. So that's what it means that forward reaction is exothermic. So when temperature of the system is, if you increase the system, temperature of this system, what will happen to the equilibrium position? So when you increase the temperature and the forward reaction is exothermic, equilibrium position is going to shift to the left. Shift to the left. So what happens when the temperature is decreased temperature of exothermic reaction? Everybody is going to shift to the what? To the right. Shift to the right. So what happens to the equilibrium constant? K will decrease. Decrease. So this value, anything that shifts equilibrium position to the right will always increase the value of what? K. So the value of K will increase. Alright, let's go to another reaction. Endothermic reaction. If the forward reaction is endothermic reaction, so it means that I increase the temperature, equilibrium position is going to shift to the what? To the right. Equilibrium position. Position will shift to the right. To the right. So what if you decrease the temperature is decreased? If you decrease the temperature, every position is going to do what? Shift to the left. So let's look at the value of equilibrium constant. So K, the value of K will increase. The value of K is going to do what? Decrease. Okay. So let's look at effect of pressure and volume change on equilibrium system. Of course, pressure affects gaseous, reactant, and what? Product. Okay. According to Boyle's law, increase in pressure results in decrease in volume. So, according to the general principle, let me use this reaction as an example. Production of ammonia gas. Okay. So look at this. This system is in equilibrium. If you increase the pressure of this system in equilibrium, so you have offset the balance. So equilibrium pressure is going to shift to cancel that effect. Okay, look at the volume of reactant and product. I have one volume of nitrogen plus 3 volumes of hydrogen. On the product side, 1 plus 3, that's 4 volumes. What I have here, volumes. So look at this here side, I have only 2. So when you increase the pressure of this system, every pressure is going to shift to the side with a lesser volume. Okay, look at this. So if I increase the pressure, when I say increase the pressure, it goes hand with a decreased volume. So when I increase the pressure of this system, every pressure is going to shift to the right because the right side has a lesser number of volume. So when I increase this pressure of this system, every pressure is going to shift to the right, favoring product formation. So you can see now, we're not talking about enthalpy change, whether it's exothermic or endothermic. That one is only for temperature only. So increase in pressure. So for this particular equation, every equation is going to shift to the right. So what happens when I lower the volume? So lower the pressure. That's what I say, increasing volume. So what happens when you decrease the pressure of this system? Every pressure is going to shift to favor the side with higher number of volume. So from right to left, you can see the increase in volume, isn't it? So when you decrease the pressure, every pressure is going to shift to the left, favoring reactant formation. So that's all about pressure and volume. When it comes to that, always check the number of moles. For gaseous reactants only. Look at this. Let's look at another example. So this reaction on the board is heterogeneous equilibrium. So the species, they are in different phase. You can see gas, you see solid. The other example, production of ammonia gas, all the reactant and product are in the same phase. So look at this. If I ask you, what happens to the equilibrium position when you increase the pressure of this system? So this solid, I'm not counting. So I have, this is steam. How many volumes? 4. This is solid. So here I have hydrogen gas. How many moles? So 4 volumes of what? Hydrogen gas. You can see the volumes of the reactant and product are the same. So pressure will not have any effect in such a system. If the volumes are the same, there will be no effect. They don't have any effect. This reaction. So look at this equation. How many volumes here? 1, 1. That is 2. Volumes here is only 2. So pressure will not have any effect in this such a system if the volumes are the same. Okay? Let's look at this solved exercise. Consider the following reaction. So this is the reaction. How would the following operation affect the position of equilibrium? So number one is removal of SO3. So removal of SO3, what happens when you remove SO3 product? Equilibrium position is going to shift to the right. So equilibrium position will shift to the right. Shift to the right. So what happens when the pressure is decreased? Decrease in pressure. Decrease in pressure means increase in volume. So decrease in pressure favors the sides with what? With larger number of what? Volume. So we'll count the volume. 2 plus 1, that is 3 volumes on the reactant side and 2 on the product side. So if you decrease the pressure, it's going to favor this side with what? Higher number of volume. So equilibrium position is going to shift to the left. Going to shift to the left. So what addition of catalyst as vanadium 5 oxide as catalyst? Catalyst does not have any effect on equilibrium position. So no effect. So what about removal of SO2? As you remove this SO2, the system is going to restore it back. So it's going to shift to the what? To the left. Shift to the left. What about decrease in temperature? So what we should watch out is the what? Enthalpy change. So this is minus. So when you lower the temperature, decrease temperature, it's going to shift it to the what? To the right. Shift to the right. Alright, we've come to the end of today's video. Thank you for watching and do have a great day.